if we have an array, okay, and this is the fixed point, and we rotate this array to here. Okay, so we want to know how much the array rotates. So how can we describe the magnitude of the array rotates? So we use which is called angles. We use angles to describe how much the array rotates. So which is we using the symbol to demonstrate this is a rotation, and we use angle. Angle is formed by rotating a ray about a point, and this point is called the vertex point. And this side is called the initial side. And this side is called the terminal side. Okay, and this is called the angle, which is about the rotation. And we use some Greek letter like alpha, beta, or theta, or other letters to describe an angle. So here are some remarks. The first one, if the rotation is counterclockwise, then by convention we say the angle formed by rotation, then the angle formed by this rotation, counterclockwise rotation, the angle is positive. If we denote this angle by alpha, so this would be the alpha is greater than 0. So in other words, this is a positive, if our rotation is from here to here, we use this arrow to denote the direction of the rotation. If this is counterclockwise, so this alpha is positive, right? So if the rotation is clockwise, then the angle is negative. We see if this angle is beta, so this beta is less than 0. So let's look at this one. Okay. And this is clockwise, right? So this beta is less than 0. So actually we give the sign for the angle. Positive means rotation is counterclockwise. Negative means the rotation is clockwise. 2. If the initial side is here and the terminal side is here, right? We have two ways to get the same terminal side. from the initial side. So we can rotate in this way, if this is alpha, and you can also rotate in this way. This is the beta. So alpha is formed by counterclockwise rotation, and the beta is formed by clockwise rotation. So these two angles have the same initial side and the same terminal side. We give a name which is called coterminal angles. Coterminal angles means this alpha, two angles, alpha, beta, have the same initial side and the same terminal side. Okay, so you can see that we have many other coterminal angles. For example, if this is alpha, let's find another one. Let's find its coterminal angles. You can rotate in the same direction, but one more round. If this is called theta, so this alpha and theta are coterminal angles. If this is the alpha, and let's rotate the initial side clockwise. Okay, so these have the same, this angle, the red angle, have the same initial side and the same terminal side, right? If this is called beta, okay? And these alpha and beta are coterminal angles. Okay. But beta is negative, right? But beta is negative. Okay, so now let's look at if we place our angle in the xy coordinate. So this is called the standard position of the angle. This is the remark 3. Standard position. The standard position means if you have xy plane, our initial side is the positive x-axis, and this is the initial side. And we rotate this initial side to here, for example. This is our terminal side. And our vertex, this is the vertex. Vertex is the origin. And this is our angle, alpha or theta. This is called the angles in this is the standard position of the angle. So here theta is positive. Right? So now we want to measure the theta. There are two different measurements. Let's look at each one by one. The first one, which is called the degree measure. The degree measure. So the unit of the degree measure is called the degree. We use this symbol. We use the circle, up circle, to denote the degree. Okay? And then we give the definition. We say, okay, if you have, this is the standard position of an angle. If we rotate one round, okay, we say this one this angle has 360 degrees. So we can define a complete revolution to be 360 degrees. So if we have this one, then the half of the revolution looks like this one, from here to here. So half of one revolution equals 360 degrees, so the half would be what? Would be 180 degrees. So here is 180 degrees. And a quarter, okay? This is the quarter. From here to here. This is a quarter. So a quarter of one revolution, which is 90 degrees. So here is 90 degrees. Okay, so if the terminal side, okay, so here is called the 0 degree. If the terminal side and the initial side in the same position, okay, we didn't rotate, so it's 0 degree. Then if we rotate to the positive y-axis, then this is 90 degree. And go back to here, this is the 180 degree. And continue, this is the 270 degree. We add 90 degree. And then we go back to our initial side. This would be the 360 degrees. So it's 360 degree and 0 degrees are exactly the same thing, okay? Although the measurements are different, but actually it looks the same, okay? So then we have, let's look at this one. Let's look at the half of the quarter, right? Which is here, half of the quarter. So this is the 45 degree. 45 degree. Okay. If we rotate, from here to here, right? Then we continue one more round. So what's this? This angle would be 45 degree From here to here is 45. Then we continue one more round, which is plus 630 degrees. So this is the 405 degrees. So this angle is 405 degrees. If we rotate in so here is also the half, okay? But we rotate from here to here. So the magnitude of this angle should be the same as this angle, right? This angle. The magnitude, right? The magnitude is the same as this angle. But the rotation is clockwise, so this is actually negative 45 degrees. So now let's look at the coterminal angles. We know that the coterminal angles share the same initial angle and the same terminal angles. So how to measure two angles are coterminal angles? One way is you can use the graph. But if the angle is large, it's not easy. So there is another way which says, okay, if the coterminal angles, then the difference between the coterminal angles is a multiple of a round, which is 360 degrees. So in other words, if you have a theta, you plus a multiple of 360 degrees. So you have n times 360 degrees. Then these are the coterminal angles. So here n could be 0, could be plus or minus 1, plus or minus 2, and so on, right? All the integers. Then these angles are coterminal angles. Okay, if you look at these two angles, right? The difference between these two angles, this is 45 and 405. If you take the difference, it would be a multiple of 360 degrees, right? Which is 1 times, or negative 1 times 360 degrees, right? So if you have, we know that this one is 90 degrees. And this one, 3/4, right? It should be 270 degrees, but rotation is clockwise, so it's the negative 270 degrees. So if you take the difference, you can see which is a multiple of 360 degrees, right? This is negative 270 degrees, right? So if you take the difference, you can see this is 90 degrees minus negative 260 degrees, which is equal to what? 360 degrees, right? Or if you take the negative 270 degrees minus 90 degrees, so this would be the negative 360 degrees. So which is, no matter which one you choose, which is always be the multiple of 360 degrees, right? So in other words, if you have, so this formula tells you that if you have an angle, how to find the coterminal angles, you just add a multiple or subtract, okay, we add or subtract 1 revolution, 2 revolutions, 3 revolutions, or n revolutions, which is a multiple of 360 degrees to get the coterminal angles. Okay, so this will give you an idea. If you're given theta, then we add or subtract one revolution, or 2 revolutions, or n revolutions. So what does this mean? This means we add or subtract a multiple of revolutions, which means a multiple of 360 degree. 1 revolution equals 360 degree, right? To get coterminal angles. To get a coterminal angle. Okay. So now let's look at the example. So if you have a 60 degree, so 60 degree is here. This is the 60 degree, which is less than 90 degree, but greater than 45 degree. So this is 60 degree. Okay, how to find? So we add, for example, let's look at if we add 1 revolution, which is 360 degree, then this one would be 420 degree. So what's that? You can rotate. So we go 60 degrees, then we continue, go 1 more round. Okay, so this angle is 420 degree. If we of course we can also subtract 1 revolution. So this one would be what? This one would be negative 300 degree, right? So actually we start from here. So this is the 60 degree, right? Then subtract, right? First we get 60 degrees, so we start from here, right? Then we subtract 1 revolution. That means we go clockwise by 1 revolution. Okay, so this angle. So here is 60 degrees, then we go back to here, it would be negative 60 degree, right? So it would be cancelled out, so we have no this part. So we only have, so actually we start from here. It looks like we start from here to get this angle. And this part, because if we beginning point is here, so this is positive, then we go back 60 degree minus 60 degree, it would be 0, right? So this part would be cancelled out, so we only have this part. Okay, so this is the 60 degree, and this red part is actually negative 300 degree. Okay, if you have another example, if you have negative 40 degree. Negative 40 degree is here. This is negative 40 degree. So we have, if you want to find the coterminal, let's look at with just the multiple plus 1 revolution. So this one would be 320 degrees. So how do we get to 320 degree? So we actually, so this is negative, right? From here, then we have counterclockwise by 1 revolution. Okay, counterclockwise by 1 revolution. Okay, and here is negative, but this part is positive. So we actually, with negative plus positive 40 degree. So it would be cancel out. Then actually, we only have this angle, right? It looks like we start from here, then to here, you will get this is 320 degree. If you have the negative 40, you have many choice, right? So here I just illustrate 2 angles, but you have infinitely many coterminal angles because n could be any the multiple. So this is n could be any integers. So here is the 2 simplest coterminal angles. So this is the negative 400 degree. How do we do that? We start from here. So this is, we use another color. Negative 40 degree. Then continue clockwise by 1 revolution. Right? From here to here, this is 1 revolution, right? So this angle is negative 400 degree. Okay, so this is the degree measurement. Let's look at the other measure, which is called the radian measure. Okay, so now let's look at how do we define a radian measure. If you have a circle centered at the origin and the radius is r, so this is a circle. A circle with radius r. Okay. If this angle is here, then it intersects the circle at this point. We denote this angle by theta. If the length of this curve, which is called the arc length, is also r, then we say this angle is 1 radian. 1 radian. Okay. So how do we define a 1 radian? We have a circle of radius r. And if this angle, this terminal side intersects at this point and this arc length is r. Arc length means the length of this curve is also equal to the radius. Then we say this angle theta has 1 radian. Okay, so this is a 1 radian. So if you have if you have still the same circle, if you have here, okay, this is theta. And this radius is r, from here to here is r. If the arc length is s, okay, the length of this part is s. So how many radians of this angle? This angle is called the central angle. Okay. How many radians? Of the central angle. Theta. How many radians? Okay. So we know if the if the arc length, this part, the length of the curve is r, then this is 1 radians. So now our length is s. So in other words, we need to know how many r's in this s, right? How many r's in this s? We say, okay, this s divided by r, which means how many r's in s, right? So this will give you the radians. So we say theta is equal to s over r radians. Okay, so from here, although we have the unit which is called the radians, but you see s is measured in meter, and if r measured in meter, then meter divided by meter, there is no units, right? So actually a number, which is the radians, means there's no unit, which is just a number, right? We have no actual units, right? Which is just a number. So if you have a number, it represents radian. Okay. So now let's define how many radians of 1 revolution. Okay. 1 revolution. We want to know how many radians. So 1 revolution, so this is the angle, theta, right? It corresponds to the arc length, which is the circumference of the circle, right? So the circumference is equal to what? If this radius is r, so it's the 2 pi times r, right? This is the circumference. So this is our s here. This s here is 2 pi over r. How many r's? We just say, okay, theta equals how many radians? So which is the corresponding arc length, which is just the circumference divided by r, right? If the arc length is r, this represents 1 radians, right? So how many r's? We divide by r. So this is the 2 pi r over r, which is equal to 2 pi radians. So most time we just suppress radians. That means we say, okay, theta equals 2 pi. means 2 pi radians. So we have the half, 1/2 revolution, which is equal to pi radians. 1/4 revolution, which is pi over 2. So if you have, so here is 0, okay? Here is 0, not 0 degree and 0. So here 0 means 0 radians. The reason is the corresponding arc length, if the coterminal side, if the initial side and the coterminal side and the terminal side, if there is no rotation, okay, no rotation, the arc length corresponding to it, which is 0. So 0 divided by r, which is equal to 0. So this is the 0 radian. And the half revolution, this is pi over 2. And if you, sorry, half rotation, this is a quarter, right? Half rotation is pi here. And to here, which is 3/4. 3/4, which is 3 pi over 2. So this is 3 pi over 2. Then go back, which is 1 revolution, which means 2 pi. Okay. So now let's look at some examples. So we want to locate where is pi over 6. So we just sketch the graph. We don't need to be precise. Pi over 6, okay, which is 1/4 is pi over 2. And the 8th quarter, half of the 1/4, which is pi over 4, right? So pi of 6 is less than the half of the 1/4, so it should be, it looks like this one. This is, it's positive, so this would be pi over 6, right? What about 9 pi over 4? Okay, so let's look at 9 pi over 4. So let's rewrite. Let's take the division. You have 9 divided by 4, you have 2. And 1 left, right? The remainder is 1. So it's 2 pi of pi plus pi over 4. It can be written as this way, right? So that means 9 pi over 4 and pi over 4 are the coterminal angles, right? So pi over 4 is the half of 1/4, which is here. Sorry, not good. Which is here. This is pi over 4. And the 9 pi over 4, we have 1 more revolution. So that is, here is pi over 4. Then 1 more revolution from, this is 1 revolution. So this is the 9 pi over 4. Okay. What about -6 pi? -6 pi, which is actually can be written as -3 times 2 pi, right? Or we can write it as 3 times -2 pi. So -2 pi is 1 revolution, but clockwise. 3 times, you have 3 revolutions with the negative direction. Okay, so now let's look at what's that. This is the 1 revolution, 2 revolution, 3 revolutions. So this is negative pi. So this is the 3 revolutions with negative direction, which means clockwise. So now, like we did in the degree measurement, to describe the coterminal angles, the same thing, we need to consider the coterminal angles in the radian measure. Okay, so the coterminal angles in the degree measure, we say if two angles are coterminal angles, then the difference is a multiple of 360 degrees, a multiple of 1 revolution. So 1 revolution in radian measure, which means 360 degrees. So now we can say coterminal angles, the difference is a multiple of 1 revolution. 1 revolution is 2 pi. So in other words, if we add or subtract a multiple of 2 pi for a given theta, then you will have its coterminal angles. So if you have a theta, right, and then you plus n times 2 pi, then these angles are coterminal angles. These angles, you have infinite coterminal angles, right? You have infinite many angles for the different choice of n, right? N is equal to 0, plus minus 1, plus minus 2, and so on. So these form coterminal angles. So if you have (13pi/6), right? Let's find the two coterminal angles. So one way is, let's find one coterminal angles. Okay, let's find one coterminal angles. So from here, so we notice that if you subtract 2 pi, which is equal to pi/6. So pi/6 is the coterminal angle. So this is pi, this is pi/6. This is pi/6. And 13 pi/6 is, this is pi/6, and 13 pi/6 would be this one, then one more round, right? This is 13 pi/6 because 13 pi/6 equals 2 pi plus pi/6. If you have an angle which is negative 2 pi/3, what is the coterminal angle? You have infinitely many, but let's find just one. So this is the negative pi. This is the negative pi over 2 pi over negative 2 pi/3. Okay, negative 2 pi/3. So the reason is negative 2 pi over 3 can be written as negative pi over 2, which is go to the negative part of the y-axis, then plus negative pi over 3. Okay. So it can be written as negative pi over 2, right? Then plus negative pi over 3. So this is negative pi over 2, and here is negative pi over 3. Okay, so this is negative 2 pi over 3. So negative 2 pi over 3, which is, let's locate this one. Let's find the coterminal angle. Okay. Okay, so give me a sec. So actually, this is the way to locate this one, locate this angle, but we can use the coterminal angles to locate the same angle, right? We don't know. If we don't know, so we want to locate this one, we have no idea, right? So let's find the coterminal angle, some angle we can easy to locate. So pi over 3, negative pi 2 pi over 3, which is equal to what? Equal to, okay, sorry, we add 2 pi to make it be positive. So we know we can easily to locate the positive angle. So this one would be 4 pi over 3, right? 4 pi over 3. So 4 pi over 3 is easy. So this is pi, right? Then plus pi over 3 would be 4 pi over 3. Pi over 3 would be here. Pi over 3 would be here. So this is the 4 pi over 3, right? And so the other angle, this would be your negative 2 pi over 3, right? Which is, the magnitude is less than pi. We didn't have half of the circle, half of the revolution, right? So negative 2 pi over 3, which is less than half of the revolution with the negative direction. Okay, so here is the one thing you should be careful when have note. Although negative 2 pi over 3 and 4 pi over 3, which are coterminal angles, that means they will share the same initial side and the same terminal side. But they are actually not the same angle. They are different. The magnitude is different, right? So now, so we have two measures. So to measure the same angle, right? So we must have some relation between these two measures. So we want to convert angles between radian and degree. Okay. And we start from here. We know one revolution is equal to 2 pi. It's also equal to 360 degrees. Okay. So if we divide by 2, so we have pi is equal to 180 degrees. So this is the relation. And if we divide by 180, what do you have? 1 degree is equal to pi over 180, right? 1 degree equals pi over 180. If we divide by pi, then it will be 1 radian equals 180 degree divided by pi. So we have 180 divided by pi degree. Okay, 1 radian. So now let's look at some examples. So if you have 30 degree, how many radians it would be? 30 degree is equal to how many 1 degree? You have 31 degree, right? 31 degree. Each 1 degree is equal to pi over 180. So 30 degree is actually pi over 6. This is 30 degree, right? And then we have 60 degree, which is 61 degrees, right? So each 1 degree is equal to pi over 180. So you have pi over 3. 45 degree, which is 45 times pi over 180. So this one is equal to what? Equal to pi over 4, right? If you have 90 degree, so this one would be 90 times pi over 180. So you have pi over 2, right? If you have negative 240 degree, which is how many degree 1 degrees you have? You have negative 241 degrees. Each 1 degree equals pi over 180. So if you simplify, it would be pi over 4, negative 4 pi over 3. So this is from the degree to the radians. Let's look at from the radians to the degree. Okay, if you have 13 pi, oh sorry, let's start from this, some special. Let's have pi over 3, okay? Pi over 3 radian, 1 radian is equal to 180 over pi degree. So it's equal to pi over 3 radians. Each radian is 180 divided by pi degree. So this is equal to 60 degree, right? Pi over 4. So this is the radians. So it's pi over 4. Each radian equals pi 180 divided by pi degree. So this one would be 45 degree, right? Pi over 6. So this is the radians, pi over 6. Each radian equals pi 180 over pi degree. So this one is 30 degree. Okay. So far our radian always has pi, but actually the radian measure doesn't mean you must have pi in the angle. For example, we know that the radian is just a number, right? We could have this one, 2.4 radian, right? This is, if you have an angle which is equal to 2.4, that means the measure is radian, okay, which is a number. 2.4, a real number, 2.4, okay? What is the degree? The 2.4 equals 2.4 times 180 over pi degree. We have 2.4 degrees. Each degree, we have 2.4 radians. Each radian equal to 180 over pi degree. So we multiply together, then use your calculator. It would be 137.5 degree. Okay. So now let's look at acute angle. Acute angle is the angle between (0 degree and 90 degree, or 0 and pi over 2. Okay. Pi over 2 equals 90 degree. And obtuse angle which is an angle between (90 degree and 180 degree, or between pi over 2 and pi. So this is called the obtuse angle. Let's look at, we have learned the coterminal angles. They share the same initial side and the same terminal side. So now let's look at another angle. If you have two angles, alpha and beta, these two angles are greater than 0. Okay? If alpha plus beta equals pi over 2 or 90 degree, then we say alpha and beta are called complementary angles. Okay, what does this mean? This means if this is alpha, and then we continue from here to here, which is beta. So you can see if we add together would be pi over 2, right? Well, which is, if you add together, which is 1/4 of the revolution. So add together would be pi over 2 or 90 degree. So these two angles are called complementary angles. So we always have alpha and beta are greater than 0. If alpha plus beta is equal to pi or 180 degree, then alpha and beta are called supplementary angles. What does this mean? This means if you have alpha here and the beta is from here to here, so you add together would be pi or 180 degree, right? If you add together. So these two angles are called supplement angles. So now let's look at if you have 2 pi over 5. What is the complementary angle? Complementary angle is, because we add another angle should be equal to pi over 2, right? So if you pi over 2 subtract this pi 2 pi over 5, then you will get its complementary angle. So which is pi over 2 minus 2 pi over 5. So if you do the calculation, it would be pi over 10. So what is the supplementary angle? Which is the sum is pi. So if you pi subtract 2 pi over 5, then you will get its supplementary angle, which is equal to 3 pi over 5. So now let's look at some applications. If you have a circle and this is the center, this is the angle, theta, the radius is r. If the corresponding to this angle, this part, this is the arc length, is s, we know how many radians. If s equals r, this is 1 radian, right? So how many r's in s? So we have s over r. So this means theta is equal to s over r radians, okay? S over r radians. But if we rewrite this one, we multiply r on both sides, then you will have what? You will have s equal to r times theta. So in other words, if we know r and we know theta in radians, then we can calculate the arc length by taking the multiplication, right? So here, one thing you should be careful is theta is in radians, not in degree. So now let's look at one example. We want to find the length of an arc of a circle with radius 10 feet. Intercepted by central angle (330°). Okay. So we want to know the arc length. So if this is the circle, right? This is the 330°, and we want to know what is the length, which is the red part. Right? Red part. Okay, so we can use the formula directly, but one thing is if you use s equals r theta, keep in mind this theta must be in radians, not in degree. So you need to convert our 330° to the radians. So the 330° is equal to 330 times pi over 180 radians, right? So it's equal to 11 pi over 6 if you simplify. Okay, so our s, the arc length s, is equal to our radius. We say, okay, the radius is 10 times the angle, which is in radians. Radians is 11 pi over 6. So this would be 55 pi over 3 feet. Okay. So this is the one application. Another application is the area of a sector of a circle. So if you have a circle here, and then you have this sector, central angle is theta, radius is r. What is the area? What's the area for the shaded region? Okay, so the area of, so let's derive the formula. If the area of this, we denote this area to be A. Okay, this is A, the area. So we use this formula. Area of the sector, a sector, over area of entire circle is equal to the central angle theta, angle theta, over the whole over 2 pi, which is the central angle for a circle, which is a 1 revolution, is 2 pi. Okay, so this area is equal to the central angle theta over 2 pi. So you will have A, which is the area of the sector, over the area of the entire circle. We have the radius, so pi r squared is the area for a circle, which is equal to our theta over pi o 2 pi. So here theta should be in radians, right? Because 2 pi is in radians. So this is the radian. So if you have, so A is equal